Hello! In this video, we're going to talk about some of the basic components of rooting theory, which are what we call points and associations. Let's start by talking about points. All a point is an object that is visually represented as a dot. So for instance, this would be a point. And the way we name points is we typically denote them by capital letters. So for instance, I might call this point, say, point P. Next, let's talk about associations. Now, all an association is an object that is visually represented as a line between 2 points. So really, what an association looks like visually is a line, and that line is between 2 points, right? So this would be an association. Okay, so then how do we name associations? Well, an association is named based on the points it is between. And what we're going to say is, if this association is between points P and Q, then we name this association by calling it P associate Q. Right? And this symbol is the association symbol. It's basically less than, squiggly, greater than, right? This is how we would name this association. And so that's pretty much the idea of a point and an association. But I would still like to go over a few rules for associations. Okay, so rule number 1. Every association is between exactly 2 distinct points. Right, and so that's the key. Exactly 2 distinct points. So, visually speaking, if I have an association, it must be between exactly 2 points. For instance, let's say these 2 points are called P and Q, and therefore we can call the association P associate Q. Well then, rule number 1 says that these 2 points must be distinct. And so this would be considered a valid association. To look at some examples of invalid associations that break rule number 1, well, for instance, we can't have an association whose ends don't have any point at all, right? We can't have an association that is between no point, right? So this would be an invalid association. We also can't have an association where we do in fact have a point at one end, but no point at the other, right? This would be an invalid association. But we also can't have an association between 2 points that are not distinct. And what that could look like is if we have an association between 2 points, but these 2 points we say are equal, right? So really, we can't have an association where the 2 points at the ends are the same, right? Theoretically, we would call this association P associate P. And these points are equal, so it breaks rule number 1. In fact, visually speaking, this doesn't really make any intuitive sense, right? Because the points are equal, we should expect the association to loop around and to connect at the same point like that, right? So this would be an invalid association, right? We can't have an association that is between 2 equal points, right? The 2 points must be distinct, like this case. Right? And another absurd example that would break rule number 1 is if we had an association between more than 2 points, which I don't even know how you could visually represent that because you wouldn't even be drawing a line, right? So something like this would be an invalid association, right? You can't have an association between more than 2 points, right? It makes no sense. Right? This right here is the only possible form that we can have, right? We must have an association between exactly 2 points that are distinct. Right? And so yeah, that's basically the idea of rule number 1. Now let's talk about rule number 2. Now rule number 2 says that if there is an association between 2 points, say P and Q, then that is the only association between those 2 points, P and Q. And to say that it is the only association between points P and Q is another way of saying the association is unique, right? All uniqueness means is that there is only one, right? So oftentimes you're going to see things worded this way. So I figured I'd introduce you to it now, right? That's all that this means. And so visually speaking, what rule 2 is getting at is, suppose we have 2 points P and Q, and suppose there actually is an association between them. Then this association is unique. In other words, this is the only association between points P and Q. We can't have another association between points P and Q like this, right? This right here is not allowed, right? If we want something that obeys rule number 2, then if we have points P and Q, and assuming there is an association between them, then this is the only association between points P and Q. Right? And so this right here is what would be valid for rule number 2. Right? And so that's pretty much the idea of rule number 2. So now let's talk about rule number 3. All rule number 3 is the association P associate Q is identical to the association Q associate P. Right? And visually speaking, what that means is, if we have an association between 2 points, P and Q, then we could call this association P associate Q, or alternatively, it's perfectly fine if we call this association Q associate P. These two things refer to the same exact association. In fact, you can actually think of associations as though they're being read as statements. What I mean by that is, the association P associate Q can be read as point P is associated with point Q. Similarly, we could read this association as point Q is associated with point P. But if these two things are equal to each other, we can really read it as points P and Q are associated with each other. Right? That's really all rule number 3 is getting at, right? We could name this association P associate Q or Q associate P. They're both the same thing. Right? And that's essentially the idea of that. So now let's talk about rule number 4, the last rule for associations. Right? The 4th rule is, visually speaking, associations do not have to be straight. Right? And so, visually speaking, right, that was good. We could have, say, points P and Q, and suppose there's an association between points P and Q. Well then, that association could be straight, but visually speaking, we don't have to represent this association as something that looks straight, right? We don't have to do that. So really, these are both valid associations. Perfectly fine. And so yeah, that's pretty much it for the rules for associations. So now what we're going to do is we're going to combine the idea of a point and an association together, right? So imagine we have a bunch of points. For instance, let's say we have something like this. And now let's say that we have some associations between these points. Let's say we have those as our associations. Now, we could think of the points as though they are locations, while the associations, we could think of those as roads between the locations, right? So we're going to define this set of points and set of associations as a map. And in general, we're going to define a map as a pair of sets, one being a set of points and the other being a set of associations. Let's say that I call the set of points V. Well, we're going to say that each association in the set of associations is between 2 points, where those 2 points both belong to V. That's what a map is. this right here is an example of a map. Now, let me list the set of points and the set of associations in this map. To do that, I'm going to have to give these points some names. So let me name these points real quick. So really, the points that are in my map are P1, P2, P3, and so on until P7. And as for the associations, we have, well, let's see, we have P2 associate P3, P4 associate P5, P4 associate P6, P5 associate P6, and P6 associate P7. And so yeah, these are the points in the map. These are the associations in the map. And notice, right, it is a pair of sets, a set of points and a set of associations. And each association that we have here is between 2 points, where those 2 points belong to this set, right? Notice P2 and P3 are both here and here. P4 and P5 are both here and here. P4, P6 are both here and here, and so on, right? So really, it obeys the rule that each association is between 2 points that belong to V, right? And so yeah, that's pretty much an example of a map, right? So yeah, that's pretty much the idea. Now, it turns out that the stuff we have talked about in this video are basic stuff in graph theory, right? Because it turns out in graph theory, points are called vertices, associations are called edges. And a map is called a graph, right? That was good, but this is the perspective that we are taking in routing theory, right? And again, it's slightly different from graph theory, but yeah, that's pretty much the idea of what I wanted to talk about in this video. So yeah, that's pretty much it.